upload it. All right, variation. So we're going to talk about our standards here today and our objectives. We're going to talk about direct, inverse, and joint variation. We're going to combine them together. Okay, so what does it mean when I say direct variation? So let's get a little vocab here. A linear function defined by the equation of the form y equals k times x, and k is a constant. That's a direct variation. And we say it y varies directly as x, or y is directly proportional to x. The constant k is called the constant of variation. It doesn't change. So if we solve for k, follow my cursor here, we solve for k, we divide by x, we would have k equals y over x, which can be used to find the constant of variation. And the equation y equals kx can be used to find the values that correspond to the direct variation. Okay, so say I tell you this. Suppose that y varies directly as x. So right now we know this. If y varies directly with x, I have y equals the constant times x. If y is 24 and x is 8, find the constant of variation. So divide by 8, guys. What would the k be? Obviously, it would be 3. So the constant of variation is 3. And the direct variation equation, and the direct variation equation would be y equals 3x. What that means is you're always going to take your x value and multiply it by 3 to get your y value. Okay, that's a direct variation. Very straightforward. It'll make sense as we progress. Okay, so Hooke's law states that the distance a spring stretches. So let's call it the distance that the spring stretches. So we'll call stretch, S, is directly proportional to the weight of the spring. So there's some constant times the weight. You know what? Instead of S, that's silly. How about distance? Right? Isn't that what we're going to find? The distance the spring stretches is directly proportional to the weight of the spring. If a 56-pound weight attached to the spring stretches 8 inches, so 8 equals k times, what was the weight of the spring? Or the weight, 56 pounds. So we're going to divide by 56. K would be, is that 1/7, right? Okay, 1/7. All right. So now I have my formula. It's always the distance equals 1/7 times the weight. Y'all follow me on this? Now we can answer the rest of the question. If a 56-pound weight attached to the spring stretches the spring 8 inches, find the distance an 85-pound weight attached to the spring stretches the spring. So then I'm going to take 1/7 times 85. Okay? Go ahead and take your calculators, take 1/7 times 85. And that distance of that spring is, we can go ahead and give me a decimal. Let's do 3 decimal places, if it, or unless it comes out evenly, which I doubt if it does. 85 divided by 7. Jessica, what do I have, hon? 12.143, and that's 12.143 inches. Is that, I believe it's correct, right? Okay. And now let's rehash real quick here, guys. Ready? We first found the constant. I then wrote the equation. I then answered the question. See how there is multiple steps to the process?
Teachers and the students at this time, we have listed the code yellow lockdown.
So, I always want the dog to come in my room. It never does. All right, inverse variation. A rational function defined by the equation in the form y equals, notice now it's the constant inversely divided by x. So we'd say y varies inversely with x. Okay? So look at this now. If you solve for k, it'd be k equals x times y. All right? So let's try it. Suppose that y varies inversely as x. Let's write right now. Y equals the constant divided by x because we're varying inversely. If y is 1/8 and x is 16, find the constant of variation and then the variation equation. Well, I just multiplied both sides by 16, right? And what's my constant of variation then? Or what's my constant of variation? Be what, guys? 2. So k is 2. And then after you know k, give me the equation. It would be y equals 2 divided by the x value. Cool? All right, let's take one and apply it now. The speed r at which one needs to drive in order to travel a constant distance, think about it, is look at it, t equals distance divided by rate. So is inversely proportional to the time. So let's see. The speed r at which one needs to drive is inversely, apologize there, inversely proportional to time. Guys, look over on up on the board. It's the constant. So in this case, it's distance, but we're going to think of the constants because it's a fixed distance. So here we go. A fixed distance can be driven in 5 hours at a rate of 24 miles per hour. So let's solve for k. 24 equals k over 5. So let's multiply both sides by 5. What's our constant, our fixed distance? What's 24 times 5? Is that 120? Yeah, okay. All right, now let's write our equation. Our equation would be r equals 120 over t. All right, and then the question then asks, find the rate needed to drive in 4 hours. So we're going to take 120 divided by 4, which obviously we know is what? 30 miles per hour. So we found the constant, we wrote our equation, we answered the problem. Easy? Okay, good. All right, now look at the chart and determine, are these values showing a direct relationship, an inverse relationship, or neither? This is what I recommend doing. Let's write y equals kx. That's direct. Everybody agree? That's direct. And inverse is y equals k over x, right? And this is how you can tell in your table if you have a direct or inverse. Do you have consistent k? So take this direct and solve for k. So the k for direct would be y divided by x. Agree? And over here for inverse, it would be k equals y times x. Everybody agree? Well, let's start off with this. If I take y divided by x, 10 divided by 2, 5 divided by 4, okay, definitely not direct. Agree? But what if I multiply them together? Do I always get the same value? Yeah, I always get what? 20. So what is it then? It's inverse. Okay, so number 5 is inverse. Questions on how I came up with that thought process. So remember this. You have this written down. This right here, look up on the screen. This and this. Okay, so when we look at the next one, see how 6 divided by 1, 12 divided by 2, 30 divided by 5, 42 divided by 7 is always the same. So this would be a direct. We good? And then when we look at this one, okay, grab your calculators. Multiply them together, divide them together. Do I get a consistent constant? I don't think either way. Am I right in that thought process? So this is not direct. It's not inverse. This would be neither. Cool? Have you ever heard in a class, maybe a science class, saying that it's inversely proportional? It's directly. I'm sure you've heard somebody say that's direct. It's directly proportional to something like that. Okay. So now look at this. We can combine with jointly. Look at this. If I say y varies jointly as x and z, y equals the constant times x and z. Y varies directly as the square of x would be y equals constant times x squared. Okay, y varies inversely as the cube of x. Look at this one. Y varies jointly with x and y. Look at that. So that's like a jointly means the same thing as directly, except several of them. And inversely with w. Okay? So you can combine it. So let's try it. Here we go. The area of a triangle is a set formula. Area equals 1/2 base times height. The area of a triangle varies jointly with its base and its height. Guys, we already know that, don't we? That constant's what always? 1/2. So you see what I'm talking about? That's a joint relationship. Suppose that y varies inversely the square of x. Let's write that formula then. If y varies inversely, constant divided by the square of x, isn't that x squared? Not square root, the square of x. Okay? Then we solve. If y is 24 when x is 2, let's see, that would be 2 squared is 4. What's 24 times 4? Because we need to find the constant. Anybody have it? Yelled out. 96. Let's rewrite our equation now. Y equals 96 over x squared. And that's it. They didn't ask for a third part. Okay? The maximum weight that a rectangular beam can support. Okay? So let's put let's call it W. The maximum. No, I don't want to do. Let's call it maximum weight. Let's call it MW. That's one variable. MW, the maximum weight that a rectangular beam can support, varies jointly with its width and the square of its height. So let's go constant times the width. That's why I use W. Times its width and the square of its height, and inversely with its length. So the maximum weight varies jointly with the width and the square of its height, and inversely with its length. Everybody cool with that? Okay, so now I give you, I give you these measurements, find K, and then find your K, and then answer the last part. I'm going to hit pause on my. So we found the constant to be 90. We plug that back into the equation. So we're finding 90 times what's the width now? 1 foot wide. 1/3 foot high, so 1/3 squared divided by its length is 9. And how many tons could that beam hold? So you have that crunch. Peyton, you have that crunch because you're sitting there. What do you got, hon?
For the maximum weight.
Yes.
I got 10/9.
10 ninths tons. And I'm okay with that. Right on the money. 10 ninths. And that's tons. Am I right? So just a little over 1 ton. Thank you. This is a pretty. Usually, you guys are pretty good. You're good at reading things. You can handle straight problems. The mathematics is not very complicated with these. All right, graphing and inverse variation. These are easy. These are easy. Okay, we're going to go in much more detail with what's going on here next class. Okay, so this is just a little intro. The graph of direct variation is a line. The graph of an inverse variation is a curve. So we're going to graph the curvatures. And it has two parts. Each part is called a branch. The x is a horizontal asymptote. The y is a vertical asymptote. Now, we'll go into more understanding about what those mean. Do you guys know what asymptotes are? They're dotted lines because they're not part of the graph, but what they do is they show where the graph is approaching. Okay, we've done horizontal asymptotes before, I know. So let's just go straight to let's go to an example here. So if I give you this inverse variation graph, we're going to have a vertical asymptote, and I'm going to use my highlighter here. Okay, we're going to have a vertical asymptote at what can x not be equal to, guys? X can't be what? 0. Agree? So we're going to have a vertical asymptote at x equals 0. The graph can't be equal to anywhere that x equals 0. Now, look up here real quick before you draw the asymptote or while you're doing it. I also could flip this around. I could also rewrite this as x equals 4 over y. That means we also have a horizontal asymptote at y equals 0. Okay? Now, we teach you a little trick to make life easy for you. So is everybody comfortable with the asymptotes? Ready? We teach you a little trick. This is positive. So that means quadrants 1 and 3. Guys, what's the square root of 4? So there is a point at 2, 2. Because I want you all to think about it. Look up here before we just assume. Everybody look up here. If I plugged in 2 for x, what's 4 divided by 2? 2. So that's why there's a point at 2, 2. Okay? Now, there's other points, but you don't need to waste your time finding them. What's going to happen is one of the branches of your hyperbola, if you will, of this inverse graph is doing this. It's approaching the vertical and horizontal asymptote in quadrant 1. Okay? Now, think about this. If I plugged in -2, follow me up here on the screen. What's 4 divided by -2? -2. So there's a point down here, and it's doing the exact same thing. It's approaching those two asymptotes in the third quadrant. Okay? Don't make it more difficult than what it is. Ready? So if I give you y equals -0.25 over x, first of all, there is a horizontal and vertical asymptote. There's a horizontal at y equals 0. There is a vertical asymptote at x equals 0. Why? Because x can't be equal to 0, and inversely y can't be equal to 0. That's why there's asymptotes. The graph can't equal those values. Okay? Question. Think of the 0.25 as 1/4. What's the square root of 1/4? 1/2, right? Everybody confident with that? Okay, now watch this. There is a point at -1/2, comma 1/2. You're going, Mr. How the heck are you getting that? Well, let me show you. Guys, if I plugged in -1/2, what's -1/4 divided by -1/2? Let's write it out if you can't see it. -1/4 divided by -1/2 would be multiplied by the reciprocal, which is -2 over 1, which gives me positive 1/2. So I have the graph, when the constant's negative, my graph is going to be in quadrants 2. And where else do you guys think? Quadrant 4. Because if I plugged in 1/2, Negative 1/4 divided by 1/2 would be negative 1/2. And I knew that because I took the square root of my constant. I took the square root of my constant. So this point's negative 1/2 comma 1/2. This point's 1/2 comma negative 1/2. So I gave you, here's your assignment. And then look, I gave you a couple problems. Guys, what's the square root of 1? 1. What's the square root of 9? What's the square root of 225? 15. So what's the square root of 2.25? 1.5. See what I'm talking about? Okay, so just practice those graphs. That's your assignment for today.